Ever wondered what it's like to drive a billion-dollar car on another planet? Well, for decades it's been less like a thrilling road trip and more like a painfully slow, high-stakes chess game. Welcome to the challenge of driving a rover on Mars, where a single wrong move made millions of miles away could end a mission. But what if I told you that the entire game just changed? NASA is now handing the keys, or at least the roadmap, to an artificial intelligence. This isn't science fiction. This is the story of how AI is revolutionizing our exploration of the red planet, turning our slow-moving rovers into nimble explorers. Let's start with the problem. What engineers at NASA's Jet Propulsion Laboratory, or JPL, call the 7-minute headache. But really, it can be up to 22 minutes. That's the time it takes for a radio signal to travel from Earth to Mars. This delay means you can't just joystick a rover around like a remote control car. If the rover spots a cliff, by the time we see it on Earth, the rover might already be at the bottom of it. Mars is a minefield of sharp, wheel-shredding rocks and treacherous sand traps just waiting to trap an unsuspecting robot. For years, the solution was painstakingly manual. Highly trained engineers would stare at satellite photos, meticulously clicking on a map to create a series of waypoints for the rover to follow, essentially drawing a dot-to-dot path to safety. It was slow, tedious, and left very little room for spontaneity or, more importantly, scientific discovery. The rover had to be smart enough to save itself from immediate dangers, but the big picture plan was all human. But in December 2025, everything changed. NASA initiated a landmark partnership with the AI company Anthropic, integrating their powerful Claude AI into mission planning. The goal was to automate the hardest part of driving on Mars, pathfinding. Instead of a human spending hours or even days poring over maps, the AI was given a massive data set. This included incredibly high-resolution orbital images from the HiRISE camera. Think of it as a powerful spy satellite orbiting Mars, and detailed 3D topographical maps known as digital elevation models. With this information, the AI could finally see Mars almost as clearly as the mission planners back on Earth. So, how does this AI master strategist actually work? It's a 3-step process that's both brilliant and incredibly cautious. First, there's the scan. The AI analyzes the 3D maps, identifying every potential hazard. It sees the steep slopes that could cause a rollover, the fields of sharp rocks that could shred the rover's wheels, and the soft sand traps that could mire it for good. It's essentially building a complete mental picture of the terrain's dangers. Next comes the waypoint party. Once it knows where not to go, the AI gets to work generating an optimal, continuous path. It doesn't just plot a few points. It creates a fluid route that navigates the landscape with an efficiency a human team could only dream of. But here's the crucial third step, the digital twin. Before sending any commands across the solar system, NASA runs the AI's entire plan through a perfect virtual replica of the rover on Earth. This digital twin simulates the drive across a virtual Martian landscape, testing over 500,000 variables. This is the ultimate safety check, ensuring the AI isn't accidentally programming our billion-dollar explorer to drive straight off a Martian cliff. It's like a final dress rehearsal before the main performance. This new system wasn't just a theory, it was put to the test. On December 8th and 10th, 2025, the Perseverance rover successfully executed its first ever drives, planned entirely by an AI model. The mission was to navigate a complex and scientifically interesting area along the rim of the Jezero Crater. The result? The rover autonomously covered a total of 456 meters, or nearly 1,500 feet, across this challenging terrain. Now, it's important to understand the division of labor here. The generative AI acted as the master navigator, setting the overall course, like a GPS telling you which highway to take on a long road trip. But the rover itself still has its own onboard intelligence, a system called AutoNav. This system is what does the real-time thinking while driving. So while the AI in California plans the route, the AutoNav on Mars is the one keeping the rover in its lane, dodging a small rock that wasn't visible from orbit or adjusting its speed on a slippery patch of dust. The AI provides the grand strategy. The rover's onboard system handles the immediate tactics. To truly grasp why this is such a monumental leap, we need to look back at the history of Mars rovers. They've always been, incredibly slow. The first rover, Sojourner, which landed in 1997, was a pioneer, but it had to stop every 5 inches to take a picture, think about its next move, and wait for instructions. It was more of a crawler than a rover. Then came Spirit, Opportunity, and Curiosity in the 2000s and 2010s. They were bigger, faster, and smarter, but still required enormous amounts of human handholding to plan their every move. Journeys that should have taken days stretched into weeks or months. Now, with Perseverance powered by AI-driven planning, NASA expects to cut route planning time in half, or even more. The rover will be able to drive for longer periods and cover far more ground each day. This completely changes the pace of exploration. So, what is the big impact of all this? It's simple. Better science, faster. By spending less time figuring out the road, scientists can spend more time doing what they sent the rover to Mars for in the first place, looking at the rocks. This new efficiency allows for what they call kilometer-scale drives. We can now explore entire valleys, crater floors, and ancient river deltas in the same amount of time it used to take to just cross a single large area. It means we can follow geological clues more quickly, analyze more samples, and potentially answer the big question, was there ever life on Mars? Sooner than we ever thought possible. We are entering a new golden age of planetary exploration, one where human ingenuity and artificial intelligence work hand in hand to unlock the secrets of the cosmos. The journey from Earth to Mars has never been shorter, and the future of discovery has never been brighter. Have you ever tried to drive a remote-controlled car from 200 million miles away? That's basically what NASA does with its Mars rovers. But there's a catch. Because of the massive distance, there's a communication delay of up to 22 minutes. That means if the rover is heading for a cliff, you can't just hit the brakes. By the time your signal gets there, it's already too late. This delay is what engineers call the 7-minute headache, although it's often much longer. For decades, navigating Mars has been a slow, painstaking process. Scientists at NASA's Jet Propulsion Laboratory, or JPL, would spend hours poring over satellite images, manually clicking on a map to create a series of waypoints for the rover to follow. It was like planning a road trip, one tiny step at a time, always worried that you might miss a sharp, wheel-shredding rock or a hidden sand trap that could end the mission. The rover had to be smart enough to handle immediate obstacles on its own, but the overall journey? That was all on the humans back on Earth. This method worked, but it was incredibly slow. The first Mars rover, Sojourner, which landed in 1997, had to stop every few inches to think about its next move. The Curiosity rover, which arrived in 2012, was faster, but still needed a lot of human handholding. Every drive was a major operation, limiting how much ground these billion-dollar robots could actually cover. The science was amazing, but the exploration was happening at a snail's pace. We were exploring a whole planet, one parking lot at a time. But what if there was a way to take the human out of the driver's seat and let an AI be the master strategist? In a groundbreaking move, that's exactly what NASA did. In December 2025, they announced a partnership with the AI company Anthropic. The mission? To use the Claude AI model to automate the most difficult part of rover driving, pathfinding. This wasn't just a minor upgrade, it was a fundamental shift in how we explore other worlds. Instead of a human spending hours choosing a safe route, the AI could do it in a fraction of the time. Here's how this revolutionary system works. First, the AI is fed incredibly detailed, high-resolution orbital imagery. We're talking about pictures from the HiRISE camera, which is essentially a powerful spy satellite orbiting Mars. These aren't just flat photos, they're used to create digital elevation models. Think of them as hyper-accurate 3D topographical maps of the Martian surface. With these maps, the AI begins its scan. It meticulously identifies every potential hazard, boulder fields, steep slopes, treacherous sand dunes, anything that could trap or damage the rover. It's like having a super scout that can see every rock and every dip in the terrain. Once the hazards are mapped, the AI gets to work on the fun part, the waypoint party. It doesn't just pick a few points. It generates a complete, continuous path from the starting point to the destination, weaving through the landscape with incredible precision. But NASA doesn't just trust the AI blindly. This is a multi-billion-dollar piece of equipment after all. Before any commands are sent to Mars, the AI's proposed route is put through a rigorous test here on Earth. They use what's called a digital twin, a perfect virtual replica of the Perseverance rover. In this simulation, they run the route through over 500,000 different variables, testing every possible scenario to make sure the AI isn't accidentally planning to drive the real rover off a cliff or into a crater it can't get out of. Only after it passes this exhaustive safety check is the plan finally beamed across the solar system to Mars. This new process was put to the ultimate test on December 8th and 10th, 2025. For the first time ever, the Perseverance rover executed 2 drives that were planned entirely by an AI. The mission was to navigate a complex area along the rim of the Jezero Crater, and the result? It was a spectacular success. The rover smoothly traveled a total of 456 meters, or about 1,500 feet, following the AI's plan. Now, it's important to understand how this works in practice. The generative AI acts as the high-level navigator, like a GPS telling you the best highway to take for your cross-country road trip. It plans the big picture, the kilometer-scale journey, but the rover still has its own onboard intelligence, a system called AutoNav. This is the real-time getting thinking while driving part. So, while the AI's plan sets the overall course, the AutoNav system is what handles the immediate environment. It's like Tesla's autopilot, keeping the rover in its lane and dodging any unexpected obstacles, like a small rock that wasn't visible from orbit. The AI provides the strategy. AutoNav handles the tactics. It's the perfect partnership between a planner in the sky and a driver on the ground. So why is this such a game changer? It all comes down to speed and efficiency. Before this, route planning was a major bottleneck. Now NASA estimates that AI can cut that planning time in half. This is a monumental leap forward. Less time spent figuring out the road means more time for the real science, analyzing rocks, searching for signs of ancient life, and uncovering the secrets of Mars. This technology unlocks the potential for kilometer-scale drives. Rovers will no longer be confined to small areas. They'll be able to explore entire valleys, climb mountains, and travel to distant geological sites that were previously out of reach. This collaboration between NASA and AI is more than just a cool tech demo. It's a paradigm shift that will accelerate the pace of planetary science beyond our wildest dreams. We're moving from cautiously tiptoeing across Mars to confidently striding across it. The next great Martian discovery might not be found by a human looking at a map, but by an AI that showed us where to go. The future of space exploration isn't just about building better rockets or rovers. It's about building smarter ones. And with AI as our co-pilot, we're ready to explore farther and faster than ever before. Thanks for watching, and if you're as excited about the future of space as I am, be sure to subscribe for more.